Hello and welcome to this week's What Were They Thinking? Among the news items we have for you this week, we're going to really trigger the hydroxychloroquine and ivermectin crowd with evidence that it really should never have been used, and especially not for the reasons that they claimed. A drug that drastically improves insulin production within 48 hours, and we're not talking about something like an insulin agitator. The Pope has rather put their foot in their mouth by claiming that surrogacy is all kinds of wrong. A nice summary of 8 of the major agricultural developments throughout history that have effectively changed life for humanity. A teenage mummy has surprising secrets from its lack of a head. Pesticides and cancer rates in farmers, and no, you are going to be disappointed by the results. NASA plans to swarm Proxima Centauri and aggravate any aliens that may be in that solar system with the astronomer's variant of spam email. And perception of time can alter wound healing, or so say some researchers. The timestamps for these and other news items can be found in the description box below. Let's start with ivermectin and hydroxychloroquine, but first ivermectin. Ivermectin was, in the early days of COVID-19, touted as a treatment that would help with COVID-19 infection. In theory, clinical trials from this would help and we'd have a better understanding, and if true, we could use it. The fact that it's not a common treatment for it now and only used by quacks on the fringe of society and idiotic doctors who have been kicked out of medical school tells you just how valid that avenue of investigation was. This has been further reinforced by research out of Brazil. The researchers were based in 12 public health clinics in Brazil, and they gave patients who had had symptoms of COVID-19 for 7 days and had at least one other comorbidity or risk factor, either ivermectin or a placebo, for 3 days. The key here is that they gave them both a treatment group and a control group, something that's often been missing from many other studies. The other issue is that many other studies have often involved, let's say, conjunctive treatment, things like extra vitamins, minerals, etc., etc. The 3,500 patients, although a relatively small cohort, is still fairly substantial, more so when you consider that only nearly 700 of those patients were in the placebo group. The remaining nearly 2,200 patients were in the treatment group, so we have a relatively large cohort to look at in terms of the actual data. The data itself is, well, to be blunt with you, rather disappointing for those who tout it as a treatment. The treatment basically didn't show anything much, and this is the key here. When you compare the treatment group, those who had ivermectin, there was about a 14 to 15% progression to hospitalization. So, to make numbers easy, 15% of those with ivermectin got sent to hospital and got hospitalized because of COVID-19. Those who received no ivermectin, therefore getting the placebo, 16% progressed to hospitalization. So clearly, ivermectin was not providing an improved outcome in that respect. There was no improvement in outcomes in terms of the clearance of the virus, secondary considerations such as the degree of severity of infection, and so on. As a result, no, there was no benefit. In fact, there is an arguable case to be made that it was possible that the researchers were trying to p-hack, as they've thrown a lot of subgroup analyses against the wall to see what would stick, and even when accounting for things like cardiovascular disease, lung disease, sex, smoking, and so on, none of these showed any benefit either with ivermectin as a use. Among the key findings of this study, apart from the fact that it proves that ivermectin does nothing, is that unlike other studies, which will often be touted by those who believe in ivermectin, it doesn't have the whole raft of issues like Didier's research that has now been retracted because it was so flawed, if not outright problematic, due to ethics issues. And now we have the other side of the crazy coin, hydroxychloroquine. Hydroxychloroquine was used as another theoretical treatment, and it has all of the same issues that ivermectin did. That is, a lack of evidence in its use, widespread application despite that, and all of the trials that have tried to prove it have often been, well, to be frank about it, terribly designed, and often fraught with problems. This brings us to what happens when we actually used hydroxychloroquine, and the study itself has found that it is possible that there were up to 17,000 deaths, and to be clear about it, these hydroxychloroquine-related deaths in hospitalization patients across 6 countries that they were studying. That's a lot more than any possible deaths associated with COVID-19 vaccination rates, and in some countries, it's significantly more than the deaths associated with COVID-19 itself. That is another way of saying, and rather long-winded way of saying, hydroxychloroquine administration killed more people than the disease or the vaccine did. Now, there is, let's say, a certain number of caveats we need to apply to this claim already, and the first of these is that it's based on systematic review and then meta-analyses of cohort studies. This is not necessarily a bad thing, but you need to be aware that this is, for all intents and purposes, a retrospective analysis of published research. What they looked at was the mortality rate and the proportion of individuals who were given hydroxychloroquine in hospitalization. That is, for those countries that had data available and the studies provided that data. This led to data being used from Belgium, France, Italy, Spain, Turkey, and the USA. Now for the actual results themselves. While we've said that there's up to 17,000 deaths, that's not quite right. That would be closer to saying that's the average. The actual range itself is arguably somewhere between 10,000 and up to 550,000, which is frankly kind of ridiculous, which is likely why they presented a more modest number in their headline. Now for how they got these results, considering that, well, not just that they're extremely high, but there's a great deal of variability between countries. The reality is that hydroxychloroquine does have some rather nasty cardiac side effects. As a result, if your heart fails and you're already on ventilation and extremely sick from COVID-19, you're probably buggered. And that's putting it nicely. As a result, there is a explanation as to why use of hydroxychloroquine could well have led to an increase in mortality. The question is whether or not that mortality is directly related to the hydroxychloroquine, and if that were not prescribed, would those individuals have survived, or did prescribing and then administering hydroxychloroquine lead to their death? And now for what is arguably at least somewhat positive and promising news on COVID-19, and it's more something that should be obvious rather than an actual development. That is that being vaccinated for COVID-19 lowers the risk of long-term COVID, or long COVID as it's otherwise called. Something that shouldn't be that surprising, given that the idea at present for long COVID is that if you are exposed to COVID, get infected, your body undergoes a series of compensatory changes and there's a certain amount of damage that occurs due to the virus. Therefore, the longer the virus has to do this damage and the longer the body has to compensate for its presence, the more you're going to have an effect over the long term. Not exactly the rocket science level, or in this case, virology level science. Instead, being vaccinated drastically reduces both of those possibilities, therefore reducing the fact that you would have to worry about the long-term effects of COVID-19. This, of course, on top of the fact that being vaccinated drastically reduces the probability of developing long COVID. Some studies placing this figure at up to a 66, if not greater percentage, drop in probability of developing long COVID. Rather than bore you with repeating what should be already obvious and what is well known, there is a link in the description box. Feel free to go through that to Scientific American and you'll find the full article with all the details related to it. And next we have improvements in diabetes. Well, specifically improvements in insulin production for those who are diabetic. Improving diabetes itself is probably the last thing they want to do. Diabetes is typified by one of two possibilities, depending on whether you're type 1 or type 2. Type 1 diabetes means no insulin production. Type 2 diabetes means either reduced insulin production, or alternatively, you have reduced insulin sensitivity. This treatment focuses on the production of insulin rather than the sensitivity, so it is, in theory, practically applicable to both type 1 and type 2, so long as there are beta cells available for type 1 diabetics, which is possibly not the case. This is where the drug in question begins working. It is a relatively small molecule, well, 2 small molecules to be specific, that target the ductal progenitor cells that are within the ducts of the pancreas. These are able to mimic the function of the beta cells that would normally produce insulin, which, especially for type 1 diabetics, who generally lack any beta cells, is incredibly important. The researchers in Australia found that by administering these 2 molecules, one being called GSK126 and the other one called tametastat, both already approved medications, they were able to increase the production of insulin within the pancreas. Now, while this is all promising and good, there is a huge caveat to this. The research is entirely based on cell culture. Yeah, that's the key here. Theoretically, since the medications are already approved in various countries for various conditions, it is possible to start clinical trials much earlier, but the results as they are now are based entirely on cells. Next we have developments related to microbiology and diseases, and it's a new antibiotic that could help with drug-resistant bacteria. More accurately, it's a new classification of antibiotics. The current antibiotics that are available are broadly broken down into various groups, and unfortunately, most of those groups are developing resistances in bacteria, the staph being particularly notorious. In this case, the drug itself is called zosusabalpin, and it's its own unique weird thing now. What makes this antibiotic particularly useful is that it is extremely effective at targeting gram-negative bacteria. Gram-negative bacteria have a double cell wall and relatively little peptidoglycan. This means that most of the medication that's good for gram-positive bacteria will not work for them. As a result, gram-negative bacteria tend to be more medication resistant than their counterparts, and it's why the majority of them, those being medication resistant, tend to fall into the gram-negative cohort. This is the issue here, but it's also why this medication is so useful. Useful, but like other results we've mentioned so far in this video, there's something of a rather large caveat. It is very much targeted at one particular bacterium. The bacterium itself is not so important, but it's what the bacterium does that is. It makes a toxin called lipopolysaccharides. These lipopolysaccharides are able to effectively harm the host, but it also makes it possible for the bacterium to embed itself within various parts of the host. The antibiotic finds its way to the transporters that are responsible for moving this toxin from inside the bacterium to the outside and blocks them up. And the idea of blocking up those portals means that the bacteria has to either stop producing the toxin, which won't happen, or it dies from its own poison, which is something of an irony. Next we have less useful research, but interesting. That is, scientists claim that life after death is impossible. Something that really shouldn't be a surprise unless you have a religious bent, and in that case, this news may or may not disappoint you. The general summary of what they found is that there is no way for there to be an everlasting presence for your consciousness after death. And the reason for that is that there is no way for a field in the universe to exist that would support that being to exist. You would literally have to be in another dimension. Put slightly differently, in order for you to be able to have an afterlife, you would have to have some sort of physical presence. The degree of that physical presence will vary drastically, and it could be very small and relatively minuscule. For example, the misunderstanding that the soul weighs 21 grams. However, that's simply not possible. There is no change in the body's mass. As a result, the soul cannot exist, and it cannot be part of the afterlife. Yeah, this one may be a bit disappointing for you. The next may at least be a little bit more entertaining, and it's, again, something of an irony. Pope Francis, the leader of the Catholic Church, has called for a universal ban on surrogacy. And not just is that an irony, but what he says about it is even worse. He says it exploits a mother and child. Talk about putting your foot in your mouth. Remember that the entire Catholic Church is premised on Jesus Christ being born of the Virgin Mary. The Virgin Mary being a surrogate for God in order to carry Jesus into the world. Although Jesus begot himself, so there's all kinds of messed up shit there. But in this case, to complain that you should not only ban surrogacy, but that it exploits mother and child, completely and ironically says that the basis of the Catholic Church existing is, well, exploitative. Yeah. Given the Catholic Church's, let's say, notorious history, exploitation is not a word that should be used lightly, and in this case, it really only serves to undermine their own existence. Shifting from news that's ironically entertaining to not so useful but interesting news, and it's mini brains that are being made. Now, the key here is that unlike other brains or brain organoids that have been made, these have been made from real tissues rather than cell cultures necessarily. The other key to this is that it's something of a problem but useful development. The first thing here is that it involves coaxing millions of cells into neurons, and then these neurons have been worked with by Dutch researchers to create organoids. Now, the organoids themselves aren't necessarily very useful. They're only about the size of a grain of rice. By taking stem cells before now, you're able to do this with just about anything, and there was trouble getting them to form a brain, but it could be done. In this case, rather than rely on creating stem cells and then pushing them into becoming brains, they've instead taken fetal stem cells that were from the brain, or what would have become a brain, and they were able to get them to effectively form a brain itself. And that's the key here. This is, controversially, from an elective abortion, and it is allowed under various ethical considerations, but nonetheless, they were able to do it. The other key difference in this research, compared to other research, is that this was a three-dimensional brain, meaning that it was beginning to form all of the necessary structures and size to be able to eventually turn into a functioning brain, although brains in a jar aren't exactly the most helpful. In terms of the ethics of the experiment, however, there is a small issue there, and a small issue in that it's entirely legal because this is purely an organoid type structure rather than a whole embryo or fetus, but they're able to grow it for up to 6 months and keep it going. It was also responsive to various stimuli, primarily chemicals, but still, it would respond. Shifting to developments that arguably aren't anywhere near as controversial, we have first of all 8 agricultural inventions that substantially changed the world. It's an interesting engineering post, and although a few days old now, it could be a good read if you wonder, how did humanity get to where it is? It talks about things like the plough, fertilizer, the thresher, cotton gin, reaper, the combine, the tractor, and finally, the most arguably controversial, genetically modified organisms, although there is a case to be made that GMOs will tie with the use of various herbicides and pesticides. in terms of GMOs, an article from The Cooldown summarizes just why GMOs are not only such a benefit, but also such a, well, not necessarily problem, but they're encountering so much resistance and difficulty. The article is all related to the use and development of a super banana, a banana that could help extensively in areas that not only have food security issues, but vitamin A deficiency. It's effectively golden rice, but in a banana. The key here is that although it is a well-established format, the approval for golden rice has been done elsewhere, and this is really just finding a new location and a new format to deliver the vitamin A. The banana itself has effectively been stuck in a camp, and the bananas in pajamas may or may not appreciate this camp. The issue with it is that the government responsible for places like Uganda really aren't in any great rush to approve it. And that's the problem here. It's not just Uganda though. There's a whole bunch of countries that basically have gone, we don't have an issue with GMOs, but we want you to provide a whole raft of evidence that we don't need for things like hybrids and similar. Yeah, most companies aren't in a rush to pay the huge amounts of money and spend the years growing these crops that would maybe get approved by the government. They'd much rather put that money towards things that would actually benefit them. And it's effectively the government stifling the innovation and approval process by expecting completely disproportionate evidence from one format, GMOs, versus others, like hybridization. Shifting from very current news to very old news. Well, old news in that it's all related to archaeology, and it's a 2,000-year-old mummy that was missing a head. Or we should say is missing a head. The excavated remains of the mummy were kept in the Smithsonian for over 100 years without much interest. All that they knew about it was that there were two remains in the mummy. One was the mummy itself, and then between its legs of the 17 or so year old girl was a second small child that had died during birth. The key here though was that the inside of the mummy was different and unique. It's where you could find a second baby, a twin to the first. Now for the mystery of the missing head. The head was attached to the mummy when it was first brought to the Smithsonian. That was well established in photographs. However, in the 100 years since, it's disappeared, which, yeah. Shifting back to agricultural news, largely because that's just disappointing, we'll talk more about controversy, and not just controversy, but what it is that's underlying it. Primarily the idea of genetic modification and how CRISPR is the tool of choice at present. CRISPR allows you to effectively cut out sections of DNA and put new DNA back in there. This new DNA generally comes in the format of genes that would alter the functionality of the plant somehow, whether that is to increase its ability to cope with salt or salinity in soil, increase yield, make it more drought resistant, and in some cases, like with banana, add vitamins that are otherwise missing from the diet. All of this is well and good. It's targeted, effective, but very expensive. And that's perhaps the big issue here. The price. Golden rice, for instance, was really only possible partly because it was, for all intents and purposes, a philanthropic project, but also down to the fact that there was a lot of funding for it. Others have not been able to do the same thing, and most genetically modified organisms are only really possible through larger agricultural companies. For example, Bayer, due to the fact that, well, it costs so much to get these plants made with the genetic modification, conduct the field trials, and then hope that you're dealing with a more reasonable government that would be willing to approve it. Now, the reality is that this is just the way a lot of research is. Some tools are going to be expensive, and the complaint by the IB Times is kind of ridiculous. That being, as quoted, there needs to be a shift towards more inclusive practices so that advancements in gene editing are accessible to a broader range of stakeholders to foster more diversification and innovation in the ag sector, end quote. Well, no, not really. The reality is that most startups find what they're trying to do incredibly expensive. This is true across all biological sciences, whether it's agricultural, biomedical, pharmaceutical, and so on. It's simply not a practical thing. It's expensive, and it generally leads to what they describe in the same article, which is once these companies get established and find a product that begins to work and is at least somewhat successful, they either get bought out by big companies or they go on themselves to become modest-sized companies. And that's the general goal of these groups or businesses. They want to build themselves up to a point where they get bought out. Yes, it would be nice if the same companies could more readily afford to do what they're doing, and particularly in the terms of agriculture where, well, the sheer number of trials and the issues with government are a problem, but these aren't unique problems to just the agricultural industry. As mentioned in past videos and in general terms, running clinical trials is expensive, and that's why pharmaceutical and biomedical companies really have a lot of trouble getting their innovations out there. It just costs so much. In rather less ridiculous news, we have actual data and numbers for the argument that using pesticides is dangerous. And short answer, no. Particularly no in terms of farmers. There have been, in recent years, a series of lawsuits against companies like Monsanto, arguing that pesticides and herbicides are dangerous, and these have all been fought out in the court, not amongst scientists. Now for actual data that shows us that at least using pesticides does not lead to cancer amongst farmers, and very clearly shows it does not cause it. First, we have the fact that most data to date has been retrospective. It's been data collected over a period of time, and then looked at summarily at the end. This has been done since the 1970s, so we do have about 50 years of research data to look at. What they found was that it was possible that there were several cancers that were more prevalent over that time. However, these studies do need to be taken with some skepticism due to the nature of what they were doing. The most fundamental of which is that unfortunately a lot of them either carried methodological flaws, there were biases in how the data was collected, or there were a range of other problems. Generally speaking, not insurmountable problems, but ones that needed time and effort. Time and effort that really wasn't forthcoming given that they were seemingly intended to meet certain goals, and not necessarily be actual science. This did lead to several very large-scale and government-facilitated studies. This did remove some of the issues around biases and methodological flaws to start with. You have the 1993 Agricultural Health Study in the USA, and in 2005 the Agricon cohort in France. That had 180,000 farmers involved. So these are quite large scale. Their findings are much clearer and, to be quite frank with it, undeniable, due to both the size and the, well-designed nature of what they were doing. There was a incidence rate of 1.1 cancers amongst farmers, so arguably there's a 10% increase in the number of cases compared to the general population, and this is both consistent in France and America when you compare the two. So there is a arguable case for a slightly higher incidence of cancer, which isn't ideal, but what is key is that the mortality rates are no different. That is, despite apparently living in an environment where they're constantly exposed to a risk factor, they don't die any more frequently than the rest of the population does. And that's the key here. Presuming that the higher incidence is representative of all farmers, which is a possibility, there may be a slightly higher risk for 3 incidences or 3 types of cancer, that being lip, prostate, and multiple myeloma. Otherwise, they're actually fairly well off. They have exactly the same risk of dying as anyone else. They have a slightly higher risk for certain things, but that could well be down to other factors than just being a farmer. For example, smoking could be a cause of lip cancer or alcohol consumption. A multiple myeloma, you have other issues there. And prostate cancer, well, a lot of farmers are male, so there could be a historical problem with that data set there. What is weird in the results from these two studies is that about a third of the cancers that they were looking into for this had a lower incidence, this being mostly cancers of the lungs, digestive tract, and bladder, seemed to be lower in those that were using pesticides. The other 2/3 of the cancers they looked into didn't have much of a difference in its prevalence compared to the general population, so there is a very weak and probably an incredibly hard to argue case that pesticides actually reduce cancer in some respects. Of course, there is a whole bunch of other issues with this, but for the most part, the results are very reliable. Confidence intervals are tight, error bars are tiny, and pretty much everything else shows that you really can't argue the results. It is entirely possible that due to the nature of farming work and its somewhat active, lifestyle, it could be that this is why it is lower, but without more clarity, it's hard to say exactly what's happening, how, and why. Shifting to the environment now, and more an interesting development rather than any necessary benefit directly at the moment. It's the shark that is regrowing a fin that was damaged several years ago. What is interesting is that the shark, having lost about 20% of its dorsal fin, that being the fin on its back, was able to not only regrow a large percentage of that damage, somewhere close to about 16% of the total fin area, meaning it's somewhere around 96% complete, which given the sheer amount of damage is surprising. The concern at the time when it was first identified is that when the fisher who had caught it, most likely by accident, had removed the marine biologist tag that was in it and butchered it so terribly, it wouldn't be able to swim properly without much damage. But it turns out, no, it's just fine. The results themselves aren't that surprising. Sharks and some other fish do have a amazing ability to regenerate damage to their body, and as such, while kind of horrifying to look at initially, the actual results are kind of predictable. Shifting to astrological news, we have the plans by NASA to pester Proxima Centauri with a whole raft of, probes. Effectively, think of mosquitoes and flies, but for astronomers. NASA's plan to spam Proxima Centauri like telemarketers relies on the use of a whole bunch of incredibly tiny probes. They're described as being gram-sized, which kind of makes sense. What they're going to do with those tiny probes is, because they are so tiny, is use lasers to propel them right the way through space and get them to Proxima Centauri much more quickly than would be otherwise available for conventional craft. A conventional craft would take somewhere between 19 and 81,000 years to reach it. The probes will be made in such a way that they weigh maybe 10 grams or thereabouts. On their front end is going to be a massive sail. Now this sail is going to be somewhat similar to what you might see on a ship of war or even a merchant ship from the age of sail. However, what will push it is not wind, although you might theoretically be able to use solar winds. Instead, it will be photons. Photons will hit this sail, and that is what will push it, but it won't be just a small amount of photons. It will be a huge amount generated by a 100 gigawatt laser. The idea is that by having such a large sail and such a tiny craft, you could get to somewhere between 10 and 20% the speed of light. While sounding kind of cool, it does have a massive caveat, and it's not just massive in terms of the size, but the time. In fact, time is the biggest issue here. It would take 8 years for data from Alpha Centauri to get to Earth. So even if, for instance, the probe was sent out tomorrow, we wouldn't get results until 2032. The final news item we have for you is more based on something interesting, but arguably a lot more questions need to be applied to this than just what we've mentioned so far. And as such, being the most tenuous news item, it is the last. the idea that altering our perception of time could alter the rate at which wounds heal. The research sounds really interesting, but it's also really dodgy. First of all, the way in which the injury was induced involved cupping. This is a modification of acupuncture, and frankly just as much bullshit. The 33 participants who underwent this therapy ended up with bruising on their skin, which is probably better than some of the more extreme cases of cupping. This was considered a minor wound. Now, the volunteers that were wounded in this way underwent 3 scenarios. One was considered the normal time scenario, lasting 28 minutes, one in a slow time scenario that lasted 28 minutes but seemed like 14 minutes, and one in what was considered a fast time scenario, again 28 minutes, but designed to feel like it was 56 minutes. The way they did this was to alter the speed at which a timer would actually work, therefore giving the impression that the speed was different, that they would watch videos with, again, altered speeds, and that they were quizzed on their wounds at a different rate. This is how the psychologists involved caused the effective perception of time to alter from what was actually happening. The key being, though, that despite one being faster and one being slower, and then the middle control, there was a consistency in how much actual time happened. All participants were given 30 minutes, or 28 minutes to be exact. On top of what we've mentioned about it all being consistent, the actual results are theoretically interesting, although at this stage very preliminary. There was more healing in the normal time condition compared to the slow time condition, and more healing in the fast time condition compared to the normal time condition. Obviously, based on that, the fast time condition is significantly better than the slow time condition. This is where the psychologists involved present a case that there is a relationship between perception of time and, as a result, the mental understanding of what's happening around you, and healing rates. However, looking at the way they presented their results, you can see that although yes, there is an average, there is a lot of variability, and the variability between a normal healing time and the perception of a slow time, therefore more time to heal, does in fact cause, well, effectively the same range of results, just with a slightly greater extent in the better healing stage. Although, again, remembering, a small cohort, so you need to be careful with just 11 people. The results really aren't able to be applied beyond the scope of what's been found at this stage. That's all the news we have for you this week. Thank you for watching. If you have found it interesting, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.